Hi students. So the part of the third unit, you guys have to learn message authentication requirements. Data is prone to various attacks, that is the sender and the receiver. The sender sends the data and the receiver receives the data. So in the network, the data can be prone to attack. So one of these attack is the message authentication. This threat arises when the user does not have any information about the originator of the message. Message authentication can be achieved through cryptographic methods, which further make use of keys. So, as part of authentication requirements, you have revelation, analysis of traffic, deception, modification of content, modification of sequence, modification in the timings, source refusal, destination refusal. So revelation, it means releasing the content of the message to someone who does not have any cryptographic key. So here is a requirement, authentication requirement. Analysis of traffic, determination of pattern of the traffic through the duration of connection and frequency of connections between different parties. So that is uh, once anyone identifies it, the hacker can identify the purpose and he can as well decipher the original message that is getting transferred from sender to the receiver. Next, modification in the content, changing the content of the message. This includes inserting new information or deleting or changing the existing one. So once the sender sends the data, the receiver receives data, the receiver receives what sender is sending. Both should be same. And deception, adding out of context messages from fraudulent source into a communication network. This will lead to mistrust between the parties communicating and may also cause loss of critical data. So once you add the extra information, unwanted information into that, right? So there will be this will actually lead to a lot of mistrust between two parties. Modification in the sequence, changing the order of the messages between parties. This includes insertion, deletion, and reordering of messages. Next, modification in the timings. So this will lead to replay and delay of messages sent between different parties. This way, session tracking is also disrupted. Source refusal, when the source denies being the originator of the message. Destination refusal, when the receiver of the message denies the reception. So these are the different scenarios where message authentication requirements are there. Next, message authentication function, message encryption. So how do you do the substitution and how do you do the transposition? Symmetric encryption. So you have DES, Blowfish and IDEA, public key encryption. You have RSA and Diffie-Hellman. You have message authentication code and hash function, which are going to learn MD5 and SHA algorithms. So you guys have to be clear with the message encryption. What are the substitution and transposition techniques that you have learned? Symmetric, DES, Blowfish idea, public key encryption is RSA and Diffie-Hellman, and hash function MD5 and SHA1. So MD5 algorithm is widely used cryptographic hash function that produces 128-bit hash value from the input message. It is mainly used for data integrity checks. So the steps are like you take input message, you convert that into binary and pad some bits to it, students, and then you then split to 512-bit each, and you initialize ABCD registers. You transform these ABCD registers for about 64 rounds. Once you get the transformed ABCD registers, you just add them to get the MD5 hash, that is 128-bit. So let's see each step. So first, you just pad. So how do you pad? Take the input hello, convert that into binary, students. Just write it And what you do is you just add the bits to the original message, the total length of 64 bits less than exact multiple of 512. Okay. So you just have to add first bit 1, all the other zeros, right? So divide that into 512 bits, block 1, block 2, block 3, block 4 until you get the total message here. And you initialize ABCD registers for 32-bit registers. You guys have to remember these values. And MD5, the one single round actually, see, functions used for MD5 processing is f of BCD, g of BCD, h of BCD, and I of BCD. What is f of BCD? B and C are not D and D. G of BCD is B and D or C and not D. H of BCD is B XOR C XOR D. I of BCD is C XOR D or not D. Okay, and single A register will be transformed like this. A equal to B plus A plus F of BCD plus M of I plus K of I. Left rotate yes, right? So M of I is 32-bit part of the message. K of I is the constant value. S is the shift amount. You can say 30 or 40. So that's how the bits will be left rotated. And for each round, ABCD will be transformed, students. And you are going to perform 64 rounds. For example, I am just showing you how A gets transformed here. Okay. And next, after processing all the blocks, students, after processing all the blocks means all the 512 blocks. All the 512 blocks, you get the transformed ABCD. You just add them, you just concatenate them to get the hash value. That is 128-bit hash value. Right? And this is the brief diagram of MD5 algorithm. This is the original message. You pad the bits and you just divide that to 512 bits. Take A, B, C, D. You just transform the 512 bits for 64 times. And the output you get is the final 128-bit message digest. Right? So this is how MD5 algorithm performs. Next algorithm, SHA1 secure hash algorithm, is a cryptographic hash function that takes as input and produces 160-bit hash. Okay, and it is used for data integrity checks. It's not recommended for security due to vulnerabilities. Okay, let's see the procedure and let's see it's not why it is not recommended for security. So you take the input message, convert that to binary, and you just pad and split that to 512. It looks similar like MD5 only, students. Say initialize H0, H1, H2, H3, H4. So here you are going to see initialize A, B, C, D here and process each block for 80 rounds. So MD5, 64 rounds. Finally, you are going to add A plus B plus C plus D. Here you are adding H0 plus H1 plus H2 plus H3 plus H4. So finally, you are going to get 160-bit hash one. Let's see each step. Take hello again, convert that into binary. You'll get this. So you are going to pad the bits. First bit is 1, all other bits are zeros. So how do you pad? Is the message length to be 448 bits mod 512. So add 1 bit at the end, and fill all the other with zeros until the total length is 448 bits. So next, once you get that, students, once padding is done, divide that to 512 blocks. So these are the 5 registers, 5 32-bit register. It's not H1, H2, H3, H4. You might want to remember this. Next, this is how these are the functions F1, F2, F3, F4, total 80 rounds, right? So round 0 to 19, F1 of BCD, B and C are not B and D. F2 of BCD, B XOR C or XOR D. F3 of BCD, B and D or B and D or C and D. F4 of BCD, B XOR C XOR D. Right? So each function modifies A, B, C, D, that is H0, H1, H2, H3, H4. So a single round. So for each of 80 rounds, the following formula is applied. So this is the mathematical operations that are applied here. Okay, it looks like some swapping function is being performed here. So A left rotate by 5 bits, F of BCD previously you have seen, and E is the A, B, C, 5 working registers, that is H0, H1, H2, H3, H4. W of I is a word, a 32-bit word derived from the message, original message. K of I is the constant value, right? So upon this step is performed for 80 times. So once you transform H0, H1, H2, H3, H4, right? You just concatenate it. So this is the output that you are going to get. This is the hash value. So this is the hash value for hello for SHA1. And if you just see for the MD5, this is the hash value. This is 128-bit students, and this value is 160-bit. Okay, but SHA1 is not secure because two different messages can produce the same hash, and SHA1 is breakable. This point to be noted, and it should not be used for password hashing or digital certificates. So you better go for SHA256. This is a popular algorithm for blockchain, right? Thank you.